I also started recording, so if you will need the recording, then I can provide you recording also. And
Oh, okay, sir.
at any stage, if you see that you are not able to you're not able to see the screen, let me know.
So,
Okay.
okay. Okay.
Otherwise, you can keep yourself muted. If you have any questions, I will ask once I will finish with a topic. Okay.
Okay. Okay.
And I don't know why other peoples are not on it yet. Do you know anyone who sent the email address and they are not? Who is
I
Jizipo
know.
and who is Lebo?
I don't know label, but I know Sharon. She's trying to log in.
Sharon, but I don't see any request yet.
Um, I'll ask her again. Let's see. She's saying she's stuck. Um, uh, let's see.
I don't see anyone yet, but I'll start in another 5 minutes. Tell me one more thing, Jizipo. You were with me in signal processing last time, or you repeating it? You are doing for the first time.
Can you repeat that, sir?
Are you doing it again, or you're doing for the first time?
It's my first time, sir.
Okay. I already started the recording of it, so if you have anything you don't want to share, you can let me know. But I will put this on the blackboard so that
Uh,
everyone can see
okay,
it.
sir.
Okay.
Okay.
So let me let me start it. I don't know how long people will take to come online. So the first topic, uh, I want to start with certain things of Fourier transform first. So you know Fourier transform. So it's if you see Fourier transform, the first thing is what is transform. So transform is basically changing the signal from time to frequency domain. And when I'm saying time to frequency, if you will say inverse transform, then it will be from F to T. So it's a method developed by someone named as Fourier. So that's why it is named as Fourier transform. Now, if you see how to find the Fourier transform, if you remember, it's f of x of t, or they represent it by x of omega also, is equals to minus infinite to infinite x of t e raised to the power minus j omega t dt. So this is the formula to find the Fourier transform of any signal. So when we are saying it's from minus infinite to infinite, it means that any signal can become in this range. So guests are waiting to join. Let me join other people also. Who is Admit. Morning, Sharon, and what's the name? Another one, Lebo.
Morning, sir.
Morning,
Can you
sir.
hear me, Lebo?
Yes, I can hear you.
Yeah. So what I did is that we are on Microsoft Team. I already started the recording of the lecture, and whatever I'm going to write, you will be able to see. So when I will be done with the topic, you can raise your questions. I will let you speak during that time. Okay. So if you have any query regarding anything, you can ask also, and you will get this video on Blackboard also once the Blackboard will start working. Till now, Blackboard is not working. Okay. But on your Microsoft Team, you will be able to see this video even though it's not on Blackboard. So if you have any queries, you can also ask, and you will have all the information in the form of video also. All right. So please let me know if you are not able to see the screen which I am using. So can you see this what I'm writing now? Both
Yes,
of
we
you.
can see.
Sorry,
Yes, we can see it.
Lebo, you can?
Yes, I can see.
Okay. So I started with a brief introduction of Fourier transform, which you might have did before this signal processing for. So in Fourier transform, we were transforming any signal which is in time domain to frequency domain, which is represented by this x omega, and this xt is given to you. So this was the formula which we were using at that time. So you were using the limits minus infinite to infinite. Minus infinite to infinite means that whatever the limits of the signal given to you, suppose xt is defined between, let's say it's equals to 2 between minus 2 to t2, then that signal will be, your integration will be equals to minus 2 to 2 x of t, sorry, this e raised to a dt. Now what is your xt? Xt is your 2. So you will write 2 here, and then you will integrate it using these limits. So this is the way you are doing your Fourier transform. So now then you are doing inverse Fourier transform. So inverse Fourier transform is basically, you say you are finding x of t where x of omega is given to you. So it was represented like this, and then you were using, the only difference is there's a 2 pi here, and then you are again integrating it within limits of minus infinite to infinite. X omega will come here, e raised to the power j omega t. There's a plus sign here, if you see, as compared to this negative sign here. And then you are integrating it with respect to omega. So that's the only difference between that 2 pi will come here and positive sign will come here. So this was you are doing to find the inverse Fourier transform of any signal given to you. Now this is basically the formula of your Fourier transform. Now if you need to find the Laplace transform, so the first thing which you need to know is now is that suppose you want to do anything in your Laplace transform, then Laplace transform is basically the main thing which I forgot to explain to you here is that that you need to study Laplace transform for this course. You need to study your jet transform for this course, and we will be doing things on MATLAB. So there will be a test 1, test 2. The test 1 will be of 10%, test 2 will be of 20%, and there will be a MATLAB submission, or you can say the practical submission, which will be of 20%. And then there will be a final assessment, which is of 50%. So let's say we are starting today. So it's 29th of August. So somewhere around 30th of September or before it, I will notify you. We can have a test 1, which will be online. It will be multiple choice questions or maybe some fill in the blanks. So you will solve everything on your notebooks, and then you will select the answers from the options given to you. Everyone understood that what we need to do for the test? Please say yes or no. You can unmute yourself.
Yes.
Yes, sir.
Okay. I'm audible to you, or I need to speak with more power?
Now you are clear, sir.
It's
Okay.
clear, sir.
So the first topic will be your Laplace transform. So the first thing which you need to understand between what's the difference between Laplace transform and the normal transform, Fourier transform, is that the Laplace transform of any signal x of t. Let me bring equation. So of x of t is equals to minus infinite to infinite integration x of t. Sorry, this side will come. Your xs is equals to this e raised to the power minus s of t dt. So if you compare it with the formula of Fourier transform, then here we have e raised to the power minus j omega t. So what's the difference between these two factors is s here is sigma plus j omega. So there is a, if I make this sigma equals to 0, so I can say that this xs is equivalent to your Fourier transform. So sigma is 0. If I say again, then sigma is 0 means, then you can say that this is x j omega equals to minus infinite to infinite x of t j omega t dt. So the, these two things are same. Now what is this sigma? Sigma is basically your damping coefficient. So if I say any signal which is given as like this, so any signal which is given as this, and I transfer it through air. So basically any signal xt is given and you are transferring through it air. So after some time, or you can say with time, this signal will have, maybe it will retain its safe shape, but you will see that the time, the amplitude will keep on decreasing. Sorry, I just draw it on the upper side. Let me draw it again. So it will be something like this. So you can see that this signal amplitude is decreasing like this, and on this side also this is decreasing like this. So this is called damping. The signal over the time reduces its amplitude, and that sigma factor is your damping factor, or you can say your damping coefficient. So over the time, the signal amplitude decreases. So when we were doing your Fourier transform, we were not including these factors. So we were, please, one, I just want to say one more thing. When I click it, sometimes it gives me the exact equation, sometimes it doesn't. So I will try to provide you a word copy of it, but don't consider the things which are getting changed after clicking to this form that they are the final answer. The finals are the one which you see in the video, which when I'm writing, or I will not click them, I'll click them later. So if I click them, sometimes they write the answers in a very different way. Just go through the video. I'll not click from here on. I'll provide you the notes later. So now, so we were doing the Laplace transform of any signal. So your x of t is your x of t is equals to minus infinite to infinite, and then x of s is equals to x of t e raised to the power minus st dt. So we can say that x of t and capital X of s forms a Laplace transform pair. LT is your Laplace transform pair. So if any signal is given to us, then suppose xt is given to us is equals to e raised to the power minus at ut, then using this formula we can find the Laplace transform. There is one more difference between Laplace transform and Fourier transform. The Laplace transform also provides us, or you can say the Laplace transform requires us to find the region of convergence. Region of convergence, which is in short form written as ROC. So it defines where this x of s converges, or convergence here means that the signal will mean signal in s domain, because we are changing our xt to x of s, the signal in s domain where it will converge, or you can say where it will exist. So if suppose x of t is given to us and we need to find the x of s of it, then using this formula x of s will be from minus infinite to infinite, x of t this. Now I don't know whether you remember ut or not, but I'm explaining you again here. So let's say your ut is your unit step function. This is unit step. So unit step function means that the signal has a unit amplitude and it is like a step, like we are taking steps when we go from, let's say, ground floor to the first floor. So we are going taking steps to go up. So if I plot it, it will be of this form. Zero, amplitude is 1, and this is t, Let's keep on changing. Let me draw it somewhere else. So this is unit step function t. This is u of t. It has amplitude 1 starting from 0 and up to infinite. So basically ut is defined as 1 for t greater than equals to 0 and 0 else. I can write it like this also. So this is your unit step function. So if I need to find the integration of this function using the Laplace transform method, then it will be x of t is equals to basically your ut. And what is ut? Ut is your 1 for t greater than equals to 0 and 0 else. Now if I integrate it, or you can say I find the Laplace transform of it, it will be from 0 to 1, the limit of integration 0 to 1, the amplitude is 1 e raised to the power minus st dt. So it will be e raised to the power minus st divided by minus s, and it will be from, why it's keep on jumping, minus s, so it's x of s will be equals to e raised to the power minus st minus s 0 to 1. So when you will put the limits of integration, it will be e raised to the power nobody said anything. I think I'm using the wrong thing here. It's ut is defined here only, and I'm using xt is equals to, so it's, this is the Laplace transform of ut only. So it will be minus s minus 1 upon s and 1. So this is the, so x of s in this case will be 1 minus e raised to the power minus s over s. So this is the Laplace transform of u of t only. This is not the Laplace transform of the function we started with. Now there is one more thing which comes into the picture, as I told you, that we have to find the region of convergence of the signal. So what is the region of convergence here? The region of convergence is always found with the help of whatever you have a function in the bottom. So what you have here in the bottom is, you will take the real part of it. So you will write real of s greater than equals to sorry, greater than 0. So that will be your region of convergence. So when you will write Laplace transform, or you will find the Laplace transform, you will not write it. This is not your final answer. You need to specify with it real of s greater than 0. So that means this function x of s in S domain will exist from S. Real means the real part of it. I will show you when there will be an imaginary part of it. What do you mean by real and imaginary? But because we talked about it, so I can tell you in brief what is real and imaginary. If you remember any complex number a plus j b, so this is called as real z plus j of imaginary z. So in this, what that means is that real of z is equals to a and imaginary of z is equals to b. So in a similar way, when we have something like this s plus a, then you can say that real of s is this a. The real part of this is this. So you can say s is, I told you, equals to sigma plus j omega. So this damping factor is your real part and this is your imaginary part. So in Laplace transform, you always draw it something like this, that imaginary s and real s. So according to your values which we will appear here, I'll explain you once as we go in the questions. So whatever the value will come, according to that you will plot them on your x-axis, or you can say real axis, or on the imaginary axis. Okay. Now I'm doing the another one of that e raised to the power, and then I will let you ask any questions if you have any. E raised to the power minus t u of t. So if we need to do the Laplace transform, again you will use the formula for this. X of s will be, this s is small, you have to remember this, x of t e raised to the power minus st dt. So that is the formula of your this, find the Laplace transform. So you can say that x of s is equals to 0 to 1. Why? Because ut is defined from 0 to 1 only. So it will be minus a of t e raised to the power minus st dt. Further to this, it will be equals to minus, sorry, 0 to 1 e raised to the power minus a plus s t dt. So when you will take the integration of it, it will be, and then there is a minus sign here, and the limits are 0 to 1. When you will apply these limits here, so it will be e raised to the power minus a plus s. I'm taking this minus s plus a common, and I'm putting these two limits. So upper limit first, and then minus lower limit. So it will be e raised to the power 0, and then it will be equals to, I'm taking now minus sign in, so let me write just without taking in, then s plus a minus 1, so it will be 1 minus upon s plus a. So if I want you to find the Laplace transform, the final Laplace transform of this, do you think that we have done it correctly or we have done it wrongly? If you see, are it certain things in a here which are not supposed to be the way they are supposed to, which I did them here, and nobody questioned me that why I'm doing it like this, even though I solved this thing also in a different way. So when I just saw it that instead of doing it t greater than equals to 0 means t greater than equals to 0 means that it is from 0 to infinite. So here I need to define it as 0 to infinite, and nobody said anything to me. I was just checking your knowledge of this course, and nobody raised any question on it. And I just keep on putting the limits. So if you see here, if you see that, then it will be e raised to the power minus st divided by minus of s, and the limits will be your 0 to 0 to infinite, means 0 to infinite. When you will put infinite, e raised to the power minus infinite is always equals to 0, and e raised to the power 0 is equals to 1. So our final answer will be 1 upon s. But none of you, maybe I didn't allow you to speak for that. But here the limits of integration, again I'm doing it so that you understand that what's the meaning of ut. Ut has an amplitude equals to 1, doesn't means that the limits of times are also 1. It's from 0 to infinite. So the limits here will go from 0 to infinite. This thing will change in a very different way now. So when you will put infinite here, when you will put infinite, this infinite here, then it will be e raised to the power minus infinite, which is equals to 0. When you will put e raised to the power 0, it will be 1. So the answer here will be 1 upon s. So in this one, it will be 1 upon s. Again here, it will be, the rule will be same because we have s here. So it will be 1 upon s. The rule remains same, but the only difference will be the excess will be 1 over s. This remains same because we have this factor here. So when you are finding it, you need to just alter it in a small way, that it will be 0 to infinite, it will be 0 to infinite. When you will put an infinite here, here, when you will put an infinite in place of t here, it will be equals to 0. When you will put a 0, it will becomes 1, and there is a negative sign, so it will be 1 upon s plus a. So 1 upon s plus a remains. The only thing which you need to find now is the region of convergence. So the region of convergence is always whatever you have in the form of s, s plus a, s minus a. You will put all of them equals to, let's not say real or imaginary. We'll say them as s plus a greater than equals greater than 0. So it is s greater than minus a. So you can write it as real s greater than minus a, or you can write it as s greater than minus a. Both the answers are going to give you the same marks for this attempt. Now I want you to ask any questions if you have regarding it, and you can tell me where I need to go, and then I'll explain according to that, and then we can take a five minutes break. Yes, Jijipo, any questions?
No questions, sir. No questions.
Sharon,
No questions, sir.
Nebo, Nebo. Okay, let's take 5 minutes break. So it's 10, can say 48 in my watch. So it's a 10:50 is that time now, and we will come back at 10:55. All right.
Okay, sir.
आपको कल के हैं वो ही नहीं लग रहा, थकान नहीं लग रही, आपकी बॉडी हमारी बॉडी तो ऐसे लग नहीं।
I hope everyone is back now.
Yes, back, sir.
Yeah. So we were here. So in this way you can find the Laplace transform of any signal. Let's take another example. So if we have this signal that, and I hope everyone is having a notebook with them, notebook and a pencil. So if I give you some question after this, then you can solve them also. Is everyone having a notebook and a pencil with them?
Yes, sir.
Okay, just keep your notebook and pencil. After solving this another question, I'll give you a question which you have to solve. So x of t suppose is equals to e raised to the power minus at u of minus t. The difference here is in the unit step signal. So in unit step signal, if it's defined for u as u of minus t, then it means if I have a signal, this is my time axis. So if you know how to do unit step, it's okay. If you don't know, then I'm telling you. Suppose let's take an example that my unit step signal is ut plus a. So how you will solve it? Whatever you have in bracket, put it equals to greater than equals to 0. So t plus a greater than equals to 0. That means t is greater than equals to minus a. So for that range which is coming from here, the signal unit step function has 1, amplitude 1 means for this range, and 0 else. So in this way you find the range of a unit step signal. Let's take another example. If you have a minus t minus a, then it is, if I use the same terminology which I used for this, so there's a recording going on, so you can see the these things later on also. So if you have t, it is minus t minus a greater than equals to 0. So this is means t plus a less than 0. If I take minus common, the sign will change. So you can say t less than equals to minus a. This signal is 1 and 0 else. So in this way you will solve any unit step function. So what unit step function we have here is u of minus t. So that means is equals to 1 for t less than 0 and 0 else. So that means this signal is something like this. So it has amplitude 1 for less than 0, and it is 0 for all the amplitudes which are greater than 0. Remember this, whatever you have a multiplication factor in to ut, that will define the amplitude. If nothing is written, that means the amplitude is 1. U means unit step. So U unit step means 1. So if something is multiplied, so if I say 2 of u of minus t, or if I say a u of minus t, then amplitude will become to 2, or maybe it will become to a. It will only change if and if you have something in multiplication. Otherwise, it remains unit, means 1. So in this way, let me check whether we are recording it again. Just checking it whether the recording is going on or not. So it's recording. Yes. Now, so we were on this question that we have to do for unit step. So in this way, the signal will be plotted. So if something like that in come in your exam, so you have to plot these signals and then you have to find the range. So now what we need to do is we need to find the integration, or you can say we need to find the Laplace transform of this signal. So how you will find the Laplace transform of this? It will be x of s will be equals to -1 to minus infinite, because it's 0, not -1. So this will be 0 to minus infinite, means 0 to, you can say it's going towards minus infinite, and you have minus e of minus 80, and then e raised to the power minus. This minus came from, this minus was from the question itself. So if I integrate it, it will be minus dt. Now you have a negative limits of your negative limits of your t. So I assume my t is equals to, let's say, p. So then dt will be equals to dp. So I can write equals to minus, I assume it equals to t equals to minus p. So that this limit here becomes positive. So dt will be equals to minus dp. When you put lower limit here, you must know how to do the limits in integration. So when you change it to another variable, so now you are changing it to another variable, because there is a minus limit here, or there is another way of this doing it. I don't want you to do it in that way, which is lower limit here. Lower limit is minus infinite. So always remember, in integration, the lower limit comes here and the upper limit comes here. So the lower limit is minus infinite, so it must come here, and the upper limit comes here. And when you change the order of the limits, there is a minus sign which comes into the picture. So we have already one minus sign here and one minus due to change in the limits, so it will become plus. So we can write e raised to the power minus, so when you will integrate it, it will be 0 to, let me change it, minus infinite to 0, which will be equals to, if you will put the upper limit, when you will put the upper limit, this, it will become 1, e raised to the power 0 is 1, and when you put the lower limit, it will become e raised to the power minus infinite. You can say plus infinite, so we'll make it 0. So what remain is 1 upon s plus a. So now you need to find its ROC. So ROC, whatever you have a factor with s or s plus a or s minus a, you will put it equals to 0, greater than 0, 0, So that is your region of convergence. Now, if I give you a question which is equals to, I want you to get ready with your pen and pencil or paper. So it's 3 e raised to the power minus 2t ut minus 2. So this is xt is equals to 3 e raised to the power minus 2t into ut minus 2 e raised to the power minus t ut. I want you to find the Laplace transform of this function, and you need to find the region of convergence also. And it's 11:06 now. My this watch, and then I'm giving you 10 minutes time to solve this problem. And don't consider it as a burden form. You can just try to solve it. If you will not be able to solve it, then I'll explain you how to solve it. So after 10 minutes, I'll come back on again, and then you have to solve. I'll ask each one of you what's your answer, and then I'll discuss it from there. Thank you. Did you hear me for that?
Can you repeat, sir, the question?
Repeat, sir.
Can you can you see the question?
Yes, sir.
So you have to solve this question, and after 10 minutes, I'll discuss this question with you. But please don't waste your time, and like you are sitting and you're not trying to solve this question. Okay, I want three of you. I think only three people are online today. So three of you to solve this question, and then we will discuss it. So you have another 10 minutes to solve this question. Okay, did you hear me now?
Yes, sir.
Yes,
Please
sir.
solve this
Yes.
question now. Lebo, I don't hear anything from you. Are you still online?
Yes, yes, I'm still online. Yes, sir.
Okay, please solve. Thank you. You have 10 minutes. तो ऐसे ही भेजा हुआ है यार, ठंडा मौसम हो गया एकदम। Are you guys done? Are you done?
Still struggling, sir.
You're struggling.
Yes, sir.
Okay, how far you are? Take another 5 minutes then. Take another 5 minutes.
आता तुम्हें समझ में नहीं आता कि मौसम खराब हो रहा है आता है फ्रेश तुम्हें समय ही हो गई थी
You guys done? You guys done or not? Hello? You guys done? Can you hear me?
We can hear you, sir.
Yeah. Are you guys done? You tried it or not? What's your answer, Jijiko?
I've got 1 over minus 3 into s plus a.
No. Labo?
For me, sir, I've got 1 over s plus 2 all to the power squared.
Sharon? Are you Sharon?
Yes, sir.
And there's a third person who's named, I think, Labo or Nebo? Labo. I think he's not. So let me solve it, and you can see what mistake you have done. So if you see that what we have is 3e raised to the power minus 2t ut. So it's basically we have to find x of s is always try to write the formula in this way. You can remember it also. This. So what we have is basically you can say we have xt as equals to x1t plus x2t, because we have to 3 e raised to the power minus 2t ut and 2 e raised to the power minus t ut, and instead of plus here we have a minus in between them. So it's basically minus infinite to infinite, and you can say 3 e raised to the power minus 2t ut. I'm connecting to you or not? Can you hear me? No.
Yes, sir, we can hear you.
Can hear you.
Yeah. What problem? Can you hear me now again?
Yes, sir.
That's due to the connection lost. 3 of you are online or not?
Seems like I'm the only one.
Sharon? What happened to Sharon?
Uh, she's trying to connect again.
And I send the request to him also. Let's see if he will come then. Who is there in the lobby? Admit. I'm admitting her, but she's on. Sorry, just I don't know what happens to the internet and it stopped working. So we were basically on, if you remember, then we were on how to solve this. Can you hear me again?
Yes, sir.
Sharon, can you hear
Yes,
me?
I can't see the screen.
And Gigi, can you see the screen?
No, sir. There's nothing.
Come on.